All right, hey Aiden, this is section 7.3. Here's the homework assignment for it. It's 1 through 10 all and 12, so just 11 problems for homework. And we're still on parallelograms for right now. Tomorrow we're going to start rectangles and squares and all that good stuff, and you guys are going to love it because it's a little bit easier, okay? So tests for parallelograms. Here we go. A lot of the same stuff as what we did in section 7.2, but here's the deal. They're going to try to do some stuff to you, and they're going to ask you some questions like this, okay? Let's say they give me this shape, and they mark it like this and like this, okay? And that's all they do. They just mark it like that, and that's it, right? Okay, what do we know from that? What does that tell us? The top and bottom are the same length, are not necessarily parallel, okay? If they tell me that, is this a parallelogram? If they label the top and bottom as the same length, does that mean it has to be a parallelogram?
Yeah.
No, because the other
What else is it going to be?
A shape that's not parallel.
If the top and bottom are equal?
Or the same length, right? Okay, let me do this. Let's
Well,
say I have this going on.
If they come to a point, then no.
This is the same length as that. There you go. Is that a parallelogram?
No.
But this is the same length as that?
Okay.
Is that a parallelogram?
That's a trapezoid.
So if they mark it with just this information, does it mean it has to be a parallelogram? If they mark it just with that information, does it have to be a parallelogram?
No.
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 What if they mark the other two sides as having to be the same length? So this has to be the same as that.
No.
Does that have to be a parallelogram? Is there any way of me moving him around so that he's not a parallelogram?
So that he's not a parallel?
Then it could just be a rectangle. Or wait, no.
But a rectangle is a parallelogram.
Okay.
It would have to be parallel.
If I mark two sets of parallel or two sets of sides that are congruent, would it have to be like this one right here? All I said was this one and this one are the same, right? So that means these two don't have to be. But if I make it so that they do have to be, does that mean it has to be a parallelogram? Yes. So we're kind of like thinking a little bit backwards. Like what has to be in place in order for this to be a parallelogram? Stop. Here we go.
You won't give me my pencil.
Okay, there are a couple requirements. There's 4 of them that have to be, like one of them has to be met. One of the 4 has to be met in order for us to have a parallelogram. So the first one, Theorem 7.9, circle him. Theorem 7.9 says that if I have 2 sets of congruent sides, then he has to be a parallelogram. Okay, so this side is the same as this side is the same as this side. I don't have to know anything about the angles. I don't have to know that this side is parallel to that one because if all the opposite ones are congruent, they will have to be parallel to each other. That's just the way it works, okay? So if opposite sides are congruent, and I know that both sets of opposite sides are congruent, that has to be a parallelogram. Got it? Okay? Now let's talk about angles. If the opposite, this is Theorem 7.10. Theorem 7.10 says, let's say we don't know anything about the sides, but we know that this angle is the same as that one and this angle is the same as that one. If that is true, and those angles have to be the same, the opposite ones, does that have to be a parallelogram? Yes. If opposite angles are congruent, we don't know anything about the sides. But if the opposite ones are congruent, then the sides have to match, right? Like the sides have to follow. All right, the third one says in Theorem 7.11, says that if I have my diagonals bisecting each other, so if they do this, and this diagonal and this diagonal, this one matches this one, and this one matches that one, if that is true, maybe I know nothing about the angles, maybe I know nothing about the sides of that thing, but that has to be a parallelogram if that takes place. If the diagonals bisect each other, this will have to be a parallelogram, right? Okay? And the last one says, and this is a weird one, so make sure you pay attention to this one or write some stuff down on this one. Here we go. This one says this. Maybe I only know stuff about one side, but I know that those two are both the same length and these two are both parallel to each other. I don't know anything about this side and I don't know anything about that side, but if this one set of sides is both congruent, meaning same length, and parallel, this will have to be a parallelogram. The other ones will have to be parallel as well. Does that make sense? Okay. So one set is the same length and parallel. This will have to be a parallelogram. One set of sides, both congruent and parallel. Okay? What happens if I do this? Is that a parallelogram? Those two angles are the same. Does that have to be a parallelogram? Let's say they're both 50
Yeah.
degrees. I don't know.
Yeah,
50 degrees and 50 degrees.
yes.
Yeah.
Yes.
They do?
If you
Yes.
change the length of any other.
710.
This guy's here. This is 50 degrees. I'm going to go like this. And I'm going to make this 50 degrees as well.
What?
50 degrees. Is that a parallelogram? I don't care what these two angles are. They don't have to be the same. But if these two match each other, does it have to be a parallelogram?
I guess if it's both pairs.
If it's both pairs, it will, right? But if it's just one pair, it doesn't
But
have to
if
be a
that-
parallelogram.
If that top one is shaped like that and the bottom one's not shaped like that,
Logically
then
it would.
yeah.
It's not.
it would,
When you can't.
because like on the top one, they're all the same, but then.
How do you know they're all the same?
Well, the first two angles are the same, and if you change the length of any of the other sides, that changes.
But I don't know
both.
anything about the sides. This side could be slightly shorter than this one.
But then the angles won't be the same.
This one would be the same as this one. Right here, I just did it. These two angles, I kept this exactly the same. And I made this guy shorter than this guy. I just tilted him up.
That changes the angle, doesn't it?
No, it changes this angle and this angle.
Look.
It changed those two angles, but it didn't change this one and this one.
You don't have to
I'm
be
so
right
confused.
every time.
No, I
Okay.
just don't understand it.
All right, Remington, ready? Here's my parallelogram.
Yes.
Okay, you got it?
Uh-huh.
This angle up here, and this angle down here are the same, right? All I'm gonna do is keep those exactly the same, and I'm gonna make a new one. So now it's like this, and there, it's like making a diamond shape, right? Or like a kite. Okay, here's what a kite looks like. Okay, in a kite, this angle is the same as that one, but those two don't have to match, right? So if they have one set of angles that's the same, it doesn't necessarily have to be a parallelogram. True? Because a kite's that way, right? If you have a kite or a diamond, right? I'm drawing really bad diamonds, but anyway, like here's my kite. Look at him, he's so cute. This angle's the same as that one, right? But the top and bottom aren't the same. So if it has one set of angles that are the same, it's not a parallelogram. Not necessarily, right? It has to have both sets, right? This one right here, theorem 710 says it has to have two sets of congruent angles, not just one set. If one set's the same, it could be a kite, right?
Yeah.
We have to be careful, okay? All right, so this one right here, they give you this information and they say, is this a parallelogram, yes or no? And they have this labeled right here. Okay, what do we know about this? If they have 12 and 5 and 12 and 5, what does that tell me? I have these two are congruent and these two are congruent. Does that thing have to be a parallelogram, or could it be like a kite or a weird thing? How do we know it's a yes?
7.9.
Yeah, theorem 7.9 says if the opposite sides are the same, like this guy right here. Theorem 7.9 says if the opposite ones are the same, opposite sides are congruent, then he has to be a parallelogram. There's no way we can position him as like a trapezoid or a kite or anything else that he's not a parallelogram.
Do you want us to justify our answer on homework?
On the homework, just put what theorem. So if it's a yes, put what theorem. If it's a no, you can't. Right? Okay, does that make sense? Okay. All right, example 2. They are saying what does X and Y have to be in order for the top of this eraser to be a parallelogram. So I see 7X right here. What's 7X have to measure if this is a parallelogram?
8.
Yeah, you did the math already. 7X has to be equal to 56, but then that means that if I divide by 7, X is 8. Okay, now I have a Y here and I have a Y here. What can I do with those two? How do I solve for Y? Send them equal. Yeah, opposite ones have to be equal. 5Y minus 26, 4Y plus 4. Let's subtract the 4Y, and I'm going to add the 26 over. So I get Y equals 30. Somebody said that already. Okay? And that's that. So in order for this to be a parallelogram, x has to be 8 and y has to be 30. Got it? Beautiful. Okay, go to the last one. We're going to skip example 4, but this is example 3. Okay, off to the right side. I'm going to show you how to do this 2 different ways. Ready? Off to the right side. Put distance. Then put slope. Okay? We can identify if it's a parallelogram on a coordinate plane by looking at the distances, and I can look at the slopes, right? So from distances, I have to have 2 sides congruent to 2 other sides. So like the top and the bottom would have to be the same length, and the 2 sides have to be the same length. We're looking at distances. This matches this one matches this one, okay? Or if I look at slopes, the opposite slopes have to be the same, okay? The opposite slopes have to be the same. So let's look at this. We're going to try to see if this is a parallelogram from 2 different standpoints. We're going to prove yes or no using 2 different methods, okay? All right, does it look like a parallelogram to begin with? Do you think yes or no? Is that a parallelogram or not? I don't think so. It doesn't look like it. It looks like this is slanted way up here and this is like straighter, right? So I don't think it's a parallelogram, but let's talk about the distances. So let's go from F to G, that's one side, okay? What's another side? G to H. Let's go H to J and then J to F.
2 over 6.
Okay. What are you talking about?
Negative 2, 6 for FG.
What?
For slope.
Oh, for slope. Okay, just wait. Hold that thought because we're doing distances right now.
Never mind.
Now, these 2 I can just count. GH is up and down. How far is GH? 4. How far is JF? 5. So as far as distance goes, this already fails, right? Because these 2 don't match each other. Okay, but let's do the other distances. So FG, let's figure out how far those are. Or like what the distance of those guys are. Okay. This is at negative 2, 4. This guy is at 4, 2. All right, so for distance y is, how far apart is negative 2 and 4? 6. And 4 and 2 is 2. 6 squared is 36. 2 squared is 4. This is the square root of 40, whatever that comes out to be. So that's one of the sides. My second side is 4. Let's go HJ. This is 2, negative 2. No, wrong. 4, negative 2. And this guy is negative 2, negative 1. Okay, so if we do the distance of this guy, how far is negative 2 and 4? 6. How far apart is negative 1 and negative 2? 1. So this is 36 plus 1, which is the square root of 37. Okay, judging from these 4 distances, is this a parallelogram?
No.
What would have to be true if this was a parallelogram?
Equal signs.
The opposite ones would have to be the same. These 2 have to be equal, these 2 have to be equal. Not true, so this is a no. Okay, now, I know that it's already not a parallelogram, but let's look at the slopes now instead. Okay, if we are trying to prove this using slopes instead, we're going to do the slopes of each one. So let's go F, we'll just go the same order that we had here. FG, GH, HJ, F, or JF. Okay. All right. FG, going from F to G. How do I find slope of that thing? Rise over run. How much is he rising? 2. He's negative 2, right? He's going down 2 and over 2, 4, 6. Down 2 and over 6. So he has a slope of negative 1/3. Yeah? Okay, GH is straight up and down. What do I put for a slope for him? What's the slope of a line that's straight up and down? Yeah, that would be at like x equals 4. What would his slope be? What is the slope if he's straight up and down?
It'd be over 0.
Yeah, so what's that mean? This guy is rising like 4. He's rising 4 and running from G to H. He's rising 4 and running 0. So what's that mean? His slope is? If 0 is on the top, then it's 0. He's undefined slope. You know how I remember that it's undefined slope? If it's a vertical line, it's not a function. It doesn't pass the vertical line test, right? You guys remember that from algebra? Like functions don't pass the vertical line test. So his slope is undefined because he's not even a function. He doesn't pass the vertical line test. What's the slope of the left side one going to be? Also undefined. Okay, so those match. That's exciting. These opposite ones match. Okay, if this is going to be a parallelogram, though, what does the third one have to have a slope of? Negative 1/3, and I bet you it doesn't. Okay, so let's go from J to H. He is going down how much? Down 1 and over 6. So his slope is negative 1/6 instead of negative 1/3. So not a parallelogram. Does that make sense? Okay, so I can prove whether it's a parallelogram or not by going by the distances or going by the slopes. It doesn't matter. Make sense? Yeah. Okay. All right, we're going to skip example 4. Your homework is there. On 1 through 6, it's a yes or a no. If it's a yes, put the theorem down. Do you want me to tell you how many yeses and nos?
Sure.
Yeah.
2 nos, 4 yeses. Okay. If it's a no, you don't have to put a reason why. If it's a yes, put the theorem down. Make sense? But there's 2 no's, 4 yeses. Got it? 1 through 10 and number 12. Perfect. Perfect, perfect. All right. Goodbye, Aiden.